Welcome to my class, dear students. Welcome. This is the part chapter HSC class, subject chemistry, chapter 2. It is second paper. Chapter 2, organic chemistry. Topics is introduction to organic chemistry, classification of organic compounds, nomenclature of organic compounds. This is not chemistry actually. Nomenclature of organic compounds. Nomenclature means naming of organic compounds. Uh, general or tribal method, and UPEC methods. Okay, two methods we use naming. Okay, what is organic chemistry? Organic chemistry is a branch of chemistry which deals with the structure, properties, synthesis, practical application of hydrocarbons and their derivative. Is called organic chemistry. Organic chemistry means the chemistry of more than one more compounds of carbon atom. In a organic compounds must contain carbon atom. So in a organic chemistry deals with the structure, properties, synthesis. Synthesis means preparation of compound from its elements. Synthesis and practical application of hydrocarbons and their derivatives is called organic chemistry. Organic chemistry means chemistry of more than one more compounds and carbon atoms. Okay, you may don't understand this. Their derivative means hydrocarbon, you know, carbon and hydrogen containing compound is called hydrocarbon. And what is their derivatives? Okay, I am showing this one, derivatives. Like this is a carbon hydrogen compound. This is hydrocarbon, carbon hydrogen containing compound methane. This is hydrocarbon. This is 4. This is hydrocarbon. This is hydrocarbon C2H6. Okay, this is hydrocarbon. Benzene is also hydrocarbon. Look this. Look. Okay, this double bond, single bond, double bond, single bond, double bond, single bond. Okay, this is benzene structure. We can write this is benzene this way. This is benzene. This hybrid structure, benzene. This way you can write. So we have understood benzene is a hydrocarbon. Carbon and hydrogen containing compound. Benzene is a hydrocarbon. This is benzene. This is hybrid structure benzene. Mm, I'm sorry, resonance structure of hybrid benzene. This benzene, what is its derivative? If one hydrogen in benzene, one hydrogen is replaced by OH. This is the phenol. So derivatives of hydrocarbons. These are also discussed in organic chemistry. Phenols. Derivative of hydrocarbon. This is the derivative of this is the hydrocarbon and this is the derivative of hydrocarbon. These are this is hydrocarbon and this one phenol is derivatives of hydrocarbons. Like this is methane. Methane is derivative if one hydrogen is replaced by OH group, then CH3 and OH. This is methanol. So derivatives of so methanol is the derivatives of methane. Okay, this the branch of chemistry which deals with the structure, properties, synthesis, and practical application of hydrocarbon and their derivatives is called organic chemistry. Organic chemistry means chemistry of more than one crore of compounds of carbon atom. It is day by day increasing. Scientist Berzelius in 1815 assumed that organic compounds obtained from plants and animals, and while inorganic compounds found from lifeless substances. Okay, but his assumed proved wrong by Frederick Bohler in 1828. He produced accidentally urea by reaction between the solution of inorganic ammonium chloride and lead cyanide. Scientist Berzelius said that organic compounds only found from plants and animals, not inorganic substance. But Frederick Bohler proved it's wrong. Has wrong. He produced accidentally urea by the reaction between inorganic ammonium chloride and lead cyanide. Look at this reaction. This is ammonium chloride and lead cyanide form ammonium cyanate. Then ammonium cyanate rearrangement when heat applied by rearrangement from urea. This urea is a organic compound. So we have found here organic compounds from inorganic substance. Organic chemistry has great contribution to every sphere of our daily life. Soaps, detergent, plastics, food products like protein, carbohydrate, vitamins, all are organic products. Other essential products are all organic products. Besides this, use of organic compounds as explosives, medicines, life-saving substance medicines, and fuels are also mentioned. These are organic substance. Classification of organic compounds. Organic compounds mainly two types: open chain compound and closed chain compound. This is 2 and is open, 2 and is closed in closed chains compounds. Open chain compound two types: saturated and unsaturated. Saturated contains carbon-carbon single bond. Unsaturated contain carbon-carbon double bond, triple bond. Carbon-carbon double bond is alkene, carbon carbon double triple bond is alkyne. Okay, close chain compound. Close chain compound mainly two types: carbocyclic and heterocyclic. Here, closed chains, but only carbon contain. So this is a carbocyclic. It is carbon with other elements content. Heterocyclic, but cycle ring content. It is also ring content. So cyclic. Here is the alicyclic. Alicyclic ring content, uh, but not benzene ring and not aromatic rings. So they are alicyclic. Aromatic ring contains compounds and aromatic. These are like benzene. Benzene derivatives are aromatic compound. Heterocyclic. Heterocyclic, heteroacyclic, and heteroaromatic. Heteroalicyclic cycle contain, but other elements contain. Okay, heterocyclic compound, carbon cyclic compound, but in a carbon with other elements present like oxygen, nitrogen, phosphorus. These are where's my cursor? Okay, this is two type: heteroalicyclic and heteroaromatic. If a aromatic compound is contain different elements, nitrogen, hydrogens, they are heteroaromatic. Heteroalicyclic, this is not aromatic, but hetero, because different elements oxygen contain, and it is ring, so cyclic. Homologous series. Homologous series, the group of compounds, the group of organic compounds formed by same elements having similar properties and a common molecular formula with reference methylene group between two adjacent compounds is called homologous series. Look at this homologous series. Uh, okay, this is methane, ethane, propane, butane. This is our homologous series. Look, there is a common general formula. This element CN H2N plus 2. If I put n equal to 1, if I put n equal to 1, if I put n equal to 1, we find methane. If I put n equal to 2, we find this compound. So they have general formula. This all elements have a general formula Cn H2n plus 2. Uh, Homologous series is a group of atoms which contains similar molecular formula, have similar chemical properties, and uh, there is a difference between two adjacent compound methylene group. Look, this compound here is a CH3 CH3, and this is compound is CH3 CH3, and this is the difference compound. This is the methylene group difference. This is called methylene group. So two adjacent compound difference is methylene group. So the group of organic compound formed by same elements having similar properties and common molecular formula with a different methylene group between two adjacent compounds is called homologous series. Now functional groups. Functional group in a compound, a element or group of elements which determines the properties of a compound is this group of element or group element is called functional group. Look this definition: the atom or group of atoms in an organic compounds of a homologous series which determine the chemical properties of the organic compounds is called functional group. The atom or group of atoms in organic compounds which of a homologous series which determine the chemical properties of the organic compound is called functional group. Either group or group of atom or group of atoms which determine the properties of a compound, chemical properties of a compound is called functional group of that compound. Like this is all carboxylic acid. Functional group is COH. COH determine the chemical properties of carboxylic acid. Sulfonic acid, CSO3H. Look, this is nitrile aldehyde. If we see SCHO, this is aldehyde. CO and this OH functional group. Look this compound. This is a methanol this is a homologous series of methanol, alcohol, homologous series of alcohol. In this these two compounds, which atom or group of atoms determine the chemical properties? This OH determine the properties of this compound. So OH is called functional group of this compound. This compound OH determine the chemical properties of this compound. So OH is called functional group of this compound. Okay, this question is very important. This calm question, like for objective question, these are what is the functional group of amide? Amide functional group is CONH2. What is the functional group of nitrile? CN. What is the functional group of aldehyde? CHO. What is the functional group of ketone? CO. What is the functional group of alcohol? OH. Like this. What is the functional group of alkene? Carbon-carbon double bond. Alkyne, carbon-carbon triple bond. Okay, this functional group one is used as a prefix. Okay, the next slide. Nomenclature of organic compounds. That means naming of organic compounds. In the beginning of organic chemistry, each new compound was given individual name. All compounds has was individual name. The ancient chemists used to depend on the success and the properties for naming compounds. Due to synthesis of large compounds, this ancient chemists used to depend on the success and properties for naming compounds. But day by day, this organic compounds, lots of compounds, millions organic compounds. So naming is by success or naming from like the formic acid is named from this acid was found in ants, so this name is formic acid. But it is not possible for large compounds. For due to synthesis of large number of organic compounds, it become very difficult to name the compounds in this basis of source or properties. For naming organic compounds, several regulated methods are as follows. Name one is general or trivial method, derived method, and UPEG method, International Union of Pure and Applied Chemistry. This method used UPEG. This is worldwide. This is latest UPEG naming. Okay, we will learn only UPEG naming today. If a chain uh, contain carbon, will add a prefix. Prefix means prefix the word or group of word which is used before the at the beginning of the word. Mit prefix it. If carbon chain is to it, if if in a carbon chain prop number of carbon is 3, prop number of carbon is 4, but number of carbon is 3, pant 5, pant number of carbon is 6, hex number of carbon is 7, hep 8, oct 9, non, and 10, dec. Look this naming nomenclature of organic compound. IUPAC method. Nomenclature of organic compounds. Okay, IUPAC method. Uh, if this methane, what is this? Meth, methane, and okay, this is methane, meth, and methane. Here is a prefix, prefix, prefix is meth, and suffix is n. Okay, if the uh, prefix prefix uh, suffix is n, look this n, suffix n. If the suffix n, compound will be alkane. Homologous series alkane. Suffix n. Alkane. Okay, suffix n. This is called one carbon. Meth, prefix is meth, so one carbon in a change. So what will be named this compound? This is n, the alkane, or meth, okay, this is alkane n. So what is general formula of alkane is general formula of alkane is CN H2N plus 2 alkane. Okay, this n, this n, suffix n. If suffix n, it will be alkane. I showed here late here, alkane. Alkane. This is alkane. So general formula is 1. So in a change is meth means prefix. Prefix meth means one carbon in change. So I'll put n equal to 1. So what will be happen? C carbon is 1, and if n equal to 1, 2 into 1 2 plus 2, 2 plus 2 4, so CH4. So methane is structural formula is methane is CH4. And what will be structure formula of ethane? Ethane, it means 2, or n means alkane, carbon carbon single bond, alkane. So what will be general formula? 2 carbon, 2 carbon. Okay, we know carbon has 4 valency, so it can form 4 bonds. At first one bond form, here one bond forms, so this carbon will form more 3 bonds. These 3 bonds form with hydrogen. Okay, okay, this carbon has one bond, so it can form more 3 bonds. These 3 more bonds is formed with hydrogen. This is the ethane. Like then propane. Propane, what will be prop and here here suffix is n, prefix is prop. So 3 carbon in a change, and n means alkane, so carbon carbon single bond. So we are now drawing here. I am doing here structure formula. At first, prop means 3 carbon in a chain. Now I am drawing this 3 carbon in a chain. I should some space here for space for hydrogen. Okay. Okay. So prop for prop 3 carbon in a chain. 1 2 3 carbon. Now I put hydrogen. Carbon can form 4 bonds. So 1 bond has present already. So later 3 bond will form with hydrogens. Okay. And now this carbon already has 2 bonds. So 2 bonds will form hydrogens. This carbon 1 bond is present, so 3 bond will form with hydrogen. Okay, this is the propane structure formula of propane. Now we will write this structure formula of we learn butane. Butane means 4. In a chain 4 carbon contain, or N means alkane, carbon single bond. So now I am drawing this one. At first I draw 4 carbon in a chain. I should take some place here. I have put some place for hydrogen. Okay. Okay, this carbon, how many hydrogen will be? 3 hydrogen, because it has 1 bond, so it form more 1 bonds, 3 bonds with hydrogens. This carbon has 2 bonds, so it need to form 4 bonds, so 2 hydrogen add. Here also 2 hydrogen. This carbon will 3 hydrogen. 3 hydrogen. Look, this 3 hydrogen. So butane structure formula I have drawn. This is the homologous series of alkane. I have today here learned alkane. Now we learn alkene. Alkene homologous series. Alkene. Alkene homologous series. This it has we can write naming from alkane name. This like this is a first one is ethane. Ethane contain carbon ethane. Here it ethane. This N, if deduct by N, ENEN, replaced by in, it become ethene. Ethene. Like this N is replaced by in, so ethene. This is okay. This is alkene. Alkene homologous series. This functional group is carbon-carbon double bond. Carbon-carbon double bond. This is the functional group of alkene. So in a alkene, if we see the in prefix, we will say, we will understand this is a alkene. At least 1 carbon bond present in a compound, or it means 2. Now I am drawing this structure formula of ethene. It means prefix it means two carbon in a chain. Two carbon in a chain. Okay. In alkene, at least carbon carbon double bond. So I should give here one double bond. So now I'll put hydrogen. So this carbon has two double bonds. So it needs two hydrogen for to form four bonds. Is hydrogen. Hydrogen can form four bonds. So here hydrogen is two bonds and two bonds with hydrogen. So total is four bonds with carbon. This carbon can form four bonds. It has already two bonds, and more two bonds will form with hydrogen. This is the structure formula of ethene. Now propane. Propane, prop means three carbon in a chain, in means alkene, at least one carbon double bond. So I should write three hydrogen, three carbon in a chain side, right? Okay. This is alkene. I can give any here any bond, double bond, at least one double bond. Now giving here double bonds. Okay. Now I put this hydrogen. So this carbon has two bonds, so more two bonds will form with hydrogen. This carbon has two bonds here and one bond here, so three bonds. So one bond will form with hydrogen. This carbon has one bond, so more three bond will form with hydrogen. This is the structure of propane. Like butane. Butane, what will be butane? At least one carbon double bond. This but means four in four carbon in a chain, or in means alkene. At least one carbon carbon double bond. So but means four carbon in a chain. So I am drawing this. Okay. This carbon has at least one bond is needed because this is alkene. I am giving here in. So it need need hydrogen. It need one hydrogen. It need two hydrogen. Because two has already three. Butane. Okay, now pentene. 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 Pent means five carbon in a chain. Pent means five carbon in a chain. So five carbon will be here. Five carbons. At first I give this five carbon. This five carbon. Okay, I have given here five carbon. I can in that alkene, so I should give one double bond. Here I give there. So it has two double bonds. This carbon, so more four bond, more two bond is needed. This two bond will form with hydrogen. This carbon, so two hydrogen here. This carbon has three bonds already, so one bond will form hydrogen. every carbon can form 4 bonds. This carbon has 2 bonds, so it form more 2 bonds with hydrogen. This also 2 bonds, it can form 2 more hydrogens. More 2 bonds will form hydrogen. This carbon has 1 bond, so it will form 3 more bonds with hydrogens. This is the pentene. Even naming is right. This right. Pentene 2. Pentene 2. I should give this is numbering. After 2 carbons, I'll give this 2, and double bond will be 2 position. Like this is it is specific. I have to give the double bond in the 2 position. So this is position 1, 2, 3, 4. If this were given like pentene 2, so I should give this is one position 1, this is a position 2. I should give position 2, and so now I am putting hydrogen. It needs 3 hydrogens. It need 1 hydrogen. This carbon need 1 hydrogen. This carbon need 2 hydrogen, and this carbon need 3 hydrogen. Okay, this is CH3. Okay, not possible here. Now I am writing here again. Pentene 2 I am writing again. How many pentene 2? Look, I am drawing this. How many carbon? Pent means 4. In means alkene. Carbon carbon double bond. This double bond position is 2. I should write at first 5 carbon. This double bond position is the 2 position, second position. 4, 5. I should get this is specify double bond. Why? The position 2. Here pentene 2. I can do put double bond any position. Here I put first. If not specify double bond. Here is a specified double bond. Double bond position have to second. So I am putting this double bond second. Okay. Now put a hydrogen. This carbon has 1 bond, so more 3 bond will form hydrogen. Okay. This carbon has 2 bonds and 1 bond, 3 bonds, and 1 more bond will form with hydrogen. This carbon has 2 bonds and 1 bond, 3 bonds, more 1 hydrogen bond form with hydrogen. This carbon has 2 bonds, so it will form 2 more bonds with hydrogen. It has 1 bond, so it will form more 3 bonds with hydrogen. So this is a pentene 2 or pentene 2 or pentene 2 or pent 2 in. same same structure formula. Pent 2 in, pent 2 in or pentene 2, same structure formula. Pent means 5 carbon in a chain, so 1 2 3 4 5, 1 2 3 4 5 carbon in a chain. And in means alkene double bond, this double bond position is 2, so double bond position is 2. Pent 2 in or pentene 2, this is the structural formula. Okay, this is the classwork. You do this classwork. uh, Classwork. Write down the structural formula. Okay, this is classwork. This is a recording class. Classwork is not possible. You do this homework. Okay, this is classwork you're doing at home. This is homework now. Thank you for joining the class. Here's the written wrong.